All right, so for this next chunk is going to represent a pretty big portion of the final exam because we did a lot to do with logarithms. And good for you, there's actually going to be a little bit of extra credit on the final exam because we didn't cover this too explicitly in class, but I'm going to show you how to do a few problems that you'll see on your practice exam. And when you get to these on the final exam, I'm going to offer them as extra credit for you as well. Okay, so let's go ahead and try and figure out what to do with each of these. Evaluating logarithms is really simple. It's just understanding the basic definition of logarithms. And what we wanted to remember is that evaluating logarithms, what we're trying to do is we are trying to find the missing exponent. Okay, if you can remember that, that's going to take you a long way in understanding how to work with logarithms. So, if you remember, what we would do with this is we would say my log base 6 of 36 is going to equal something, but I'm not sure what. And here's how I approach these problems. I would say, well, base 6 raised to the question mark equals 36, and I'll rewrite it. 6 to the what equals 36. And then I can figure out just by intuition that 6 squared equals 36. So what does my question mark equal, or what is log base 36? So we say log base 6 of 36 is going to equal 2, and that's my answer. Your calculator can make pretty quick work of this too, but a lot of calculators don't have the option where you can change the base from 10 or from that natural number e. So we'll do the same thing with this one. Say here's my question mark that I don't know. 7 to the what power equals 343, and I can rewrite that to help me understand. 7 to the what power equals 343, and I don't know my powers of 7 very well, so I just need to start multiplying by 7. 7 times 7 is going to equal 49, and 49 times 7, I can't do that one in my head, so I need to try and do this. 9 times 7 is 63, carry the 6, 4 times 7 is 28, plus another 6 is 343, and there it is. So how many 7s did I multiply? 1, 2, 3. What that tells me is that 7 raised up to the third power is going to equal 343. So, what is log base 7 of 343? It is equal to 3. Finding the missing exponent. That's all it is. So now let's go ahead and move on to properties of logarithms. And what we mean with properties of logarithms is we are going to talk about expanding and condensing logarithms. Okay, so these are problems that are going to represent a couple of extra credit opportunities again because we didn't cover them, but we can teach them to you real quick because it's not very tough. Okay, so we have log of x times y. If we are taking the product of two logarithms, then we can actually separate that out by addition. So if I'm multiplying two numbers inside of a logarithm, then I can actually separate that out into two logarithms where I'm adding them together. And I can see that being applied right here. Right? So these first few that I'm looking at here is I can separate this out then as log base 6 of 3 plus log base 6 of 10 plus log base 6 of 11 to the 6th power. Okay? So that one has been applied pretty easily. The next thing we can do is we can look at division. If we are taking the quotient or dividing two numbers in a logarithm, then that's going to be very simply log of x minus log of y. It's like I'm subtracting those two. Okay? So what that actually tells me is that I can kind of rethink about this is that anytime that I have something like this where I have log of 10 over 5, it's the same thing as log of 10 minus the log of 5. And that means the same exact thing. Okay? The last property that we have is called the power property, and it says that log of x to the a power, all you have to do with that a is you can just say, I don't want it there, I want to move it to the front, and it becomes a times log of x. So if I wanted to take the log of x squared, that's exactly the same thing as saying 2 times the log of x, where I just take the exponent and I move it in front of the logarithm. So that means I can apply to this same problem that I was looking at, log base 6, 11 to the 6th power, I can separate that last part out a little bit better. So the first thing I can do is rewrite these, log base 6 of 3 plus log base 6 of 10, and then I can move this 6 to the front here, and I'd say that's going to be 6 log base 6 of 11, and I have completely expanded that logarithm. Okay, we can also try and do this with things that aren't quite as intuitive. First thing I'm going to do is look at this one. I'll say 5. That can move to the front. Okay, let me separate this out a little bit. And I'll say that's going to be 5 log base 7 of 24. Okay, but what I recognize too is that sometimes this is helpful where I can apply another one of these properties and I can separate this out. I can expand this logarithm. So I can think of what two numbers can multiply together to give me 24. Well, there's 8 and 3. Now you could also use 12 and 2. You could use 6 and 4. It doesn't really matter here. But what that means is that I can have this be 5 log base 7 of 8 plus 5 log base 7 of 3, because these two numbers, 8 and 3, multiplied together would give me 24. Okay? And now we've completely expanded that one. Next one to take a look at is going to be this one here, where we have 10 log base 7 of u plus 2 log base 7 of v. Okay, so with this one, I actually want to condense. I want to say, oh, there's a number in front of my log. That means that can go up to the front or up into the exponent level. So I have log base 7 of u to the 10 plus log base 7 of v squared. And then what I realize is that I can go ahead and combine these two by looking at addition. And I can go the other direction of this first property that I had, and I can say that since they both have the same exact base, log base 7, I can write them together as one logarithm, and this is much more common what we end up doing. So that's log base 7 of v to the 10, u to the 10, u to the 10, v squared. And this whole thing is inside a logarithm. Let me write that a little bit more cleanly. We'd say that's log base 7 of u to the 10, v squared. And that has been condensed. We'll do the same thing with this one. I see that there's subtraction there, and I also see that I have the same base. So first thing I want to do is take these numbers and move them up to the exponent level. Okay, so that means I've got log base 8 of 7 to the 6th minus log base 8 of 10 to the 30 power. And then since it's subtraction, I'm going to go ahead and make them as a division of one logarithm. So it's log base 8. Anything that has a positive coefficient in front of it, like the log base 8 of 7 to the 6th, that's going to go in my numerator. So that is going to be 7 to the 6th power. Anything with the negative exponent, sorry, not negative exponent, but negative sign in front of the log is going to go into the denominator. So that's log base 8 of 7 to the 6th over 10 to the 30. And those are properties of logarithms that we can utilize. Okay, so that's that. See if you can't do the problems from your practice tests for those. Finally, the last one we're going to look at is solving log equations. So these seem like they're going to be complicated, but they're actually really easy, and they work very similar to the exponential equations that we were working with before. What we want to try and do is get the same base of the logarithms if we've got multiple logarithms. So here I see that I've got log base 12 and log base 12. Once I see that, the only things I really need to focus on are the things I'm taking the logarithms of. I don't need to worry about anything else. So this can just be rewritten as the equation based on what we are taking the log of, and that's 2x minus 1, 5x minus 1, and we are going to do some simple algebra to try and solve for this equation. So I'm going to move my 2x over to the right-hand side, and I'm going to move my negative 1 to the left-hand side. So those cancel out. Those cancel out. And then I have negative 1 plus 1. Well, that's 0. 5x minus 2x, that's 3x. What do I do to get x by itself here? I'm going to divide by 3. And we can divide 0 over 3. We couldn't divide 3 over 0, but we can do 0 over 3. So my answer really is just 0 equals x. Super simple, right? We're taking something algebra 2, recognizing its pattern, and turning it into algebra 1. Okay? For this one, we're going to do some of the algebra 1 stuff first. So what we want to try and do is whatever I'm taking the log of, I want to get this by itself. So I see two things that I can move. There's the negative 5 and the 3. So let's go ahead and move those. I'm going to first start by moving this negative 5 to the other side. Those go away, and that gives me 9. And on the left-hand side, I have 3 log base 3 of x plus 9. Then I'm going to take a look at, okay, what can I do to get rid of this 3 here? Well, that's multiplying by 3, so let's go ahead and divide both sides by 3. That's going to cancel those out, not the base of my logarithm, just the 3 as a coefficient. And we have log base 3 of x plus 9, but I had to make sure I divided by 3 on both sides, and that's 9 divided by 3, which gives me 3. So now this actually looks a lot like one of the evaluating logarithms questions, right? Let's go ahead and try and evaluate this or rewrite it. And the way that I do that is I say, well, hey, 3 to the what power gives me x plus 9. And we say we can rewrite this as 3 to the third power equals x plus 9 just by following the arrows, rewriting it. And I can evaluate this left-hand side. 3 to the third power, that's 3 times 3, 9 times 3 again, 27. Equals x plus 9, and then I do my last step of subtracting 9 on both sides, and that's going to give me my final answer, where x will equal 18. Done and done. Okay, so the other problems that you're going to see are going to be ones that are word problems. Do your best with those. So try them on your own, think about it, and then come back to me if you've got any questions. Thank you guys. Enjoy.